Hi folks, I just wanted to make a quick video to help you out with number 13 from our assignment for section 7.4. The first thing I did was I copied the problem. So if you want to take a second and jot that down, that would be amazing. So number 13 was y equals 5 raised to the 1 plus x plus 1, that's your numerator, all over 5 to the power of x. The first thing I want to draw your attention to is what this actually means. Now, I know our normal first step is to switch x and y, but I thought that at this point in time, it's actually just easier to make this a simpler looking problem to start. So instead of just switching x and y to start this off, I was like, wait, this is a mess. So I'm going to go ahead and just simplify some things a little bit. So I took this 5 raised to the 1 plus x, and I thought, what does it mean, when I'm adding my exponents together? And when we add our exponents together, that's the result of finding a product with like bases. So if you think about it, 5 to the first times 5 to the x is the same as 5 to the 1 plus x. So the first thing I did was I wrote this down. Why I did that is because eventually I want this 5 to the x power to go away. We don't like fractions. We try to get rid of them. I want them gone. So that's the avenue I was going to take. And, if we notice, we're starting to see we have a factor of 5 to the x now coming out in the numerator. It's having this factor that's going to allow me to get rid of this 5 to the x on the bottom. So that was my problem-solving process, is like, I want this gone. So that's kind of what led me to think about rewriting this in a different way. So that's the first thing I did, is I used my product rule for exponents to rewrite 5 raised to the 1 plus x as 5 to the first times 5 to the x power. It's pretty rare that we work those properties backwards, but super handy and gives you some flexibility in your thinking. Okay, so back to that whole idea, I want this 5 to the x power to be gone. What I'm going to try to do is pull this 5 to the x out as a GCF. And you might be looking at it like, Mrs. Lucas, 1 doesn't have a factor of 5 to the x in it. Well, it kind of does if you think about it. So I went ahead and I pulled out this 5 to the x like it was a GCF. And then 5 to the x times 5 to the first gets me my first term. And then if I do 5 to the x and I pull it out of this 1, essentially all I'm doing is taking 1 and dividing it by 5 to the x. So if I did 5 to the x times 1 over 5 to the x, I would get 1. They would cross cancel. So these two things actually do make 1 when you multiply them together. And then the magic happened. So I have 5 to the x on the outside over 5 to the x on the bottom. So now I can go ahead and simplify. So I'm going to cross those 5 to the x's out because they do cancel. And I'm left with y equals 5 plus 1 over 5 to the x. A much simpler looking problem. So now I'm going to go ahead, now that I've reduced the problem down a little bit, now this is a problem that would be fair game for a test. If I asked you to write the inverse of this, the expectation would be that you could do that. So now we're kind of starting from our normal step 1. We switch our x and our y. And again, the goal after we switch our x and our y is to get this y by itself. So to do that, I do have to subtract 5 from both sides. So that'll leave me x minus 5 there on the left, and 1 over 5 to the power of y on the right. Still, I need to get this, 5 to the power of y by itself. I am going to go ahead and multiply both sides by 5 to the y to get that 5 to the y to pop upstairs. And what I'll have there is 5 raised to the power of y equals x minus 5. Or I'm sorry, 5 to the power of y times x minus 5. That equals 1. And then I'm going to get rid of this x minus 5 here. Almost done. So I have 5 raised to the power of y equals 1 over x minus 5. So now I can write my log. So I have log base 5 of 1 over x minus 5. And that's finally equal to my y. So we could also write this as f inverse of x equals log base 5 of 1 over x minus 5. Super challenging problem on many levels. Definitely not one you would see on your test, but definitely good for you. Lots of old and new algebra embedded in that problem. Hope it helps.